Saturn, the sixth planet from our Sun and the second largest planet in our solar system next to Jupiter. 7 bright objects have been seen in our sky since the dawn of time: the Sun, Moon, Mercury, Venus, Mars, Jupiter, and Saturn. In ancient Rome, the Romans gave these objects names after the powerful gods. Saturn was the god of agriculture, where he ruled the city of Latium and taught his people how to farm. In Greek myth, it was known as Cronus. Although Saturn is visible with the naked eye, our eyes fail to show us Saturn's glorious rings and moons. In 1610, Galileo Galilei first observed Saturn's rings. He had already discovered Jupiter's moons, but Saturn was more of a challenge, being twice as far from Jupiter. Due to his telescope not being powerful enough, he saw the rings as 2 large moons next to the planet. 2 years later, after viewing Saturn again, the moons had disappeared. After another 2 years, he had seen the moons return, and he came to the conclusion that the rings were arms that were attached to the planet. In the 1650s, with improvements in telescope optics, Dutch scientist Christian Huygens was able to determine that Saturn had rings. Upon this, Huygens also discovered the first moon of Saturn, which he named Titan. In honor of him, we named the probe exploring Titan after him. Saturn orbits an average distance of 886 million miles away from the Sun, 10 times farther from the Sun than Earth. In astronomical units, it is 9.5 units away from the Sun. 1 astronomical unit is the distance from the Sun to the Earth, which is 93 million miles. We use this measurement due to the distances in space being far too large. At 1 AU, light from the Sun takes 8 minutes to reach the Earth. On Saturn, light has to travel 80 minutes before reaching the planet. Saturn also has a radius of 36,183 miles, which is 9 times wider than the Earth. Saturn is also large enough to be filled with 760 Earths and is 95 times more massive than the Earth. Earth takes 365 days or 1 year to complete 1 revolution around the Sun. For Saturn, it takes 29.5 Earth years to complete a full revolution. Saturn also has a very short day length of only 10.2 Earth hours. Due to Saturn spinning so fast, it bulges at the equator. The other gas giants bulge like this as well, but is more pronounced on Saturn, making it the flattest planet in our solar system. Saturn is a gas giant, meaning it is made predominantly of gas with little solid surface. The atmosphere is mainly composed of hydrogen and helium, with other trace molecules present as well. The faint bands seen in the atmosphere are caused by extremely fast winds, faster than on Jupiter. Being composed of light elements, this causes Saturn to have a density less than water. This means that if there was a bathtub large enough, Saturn would float. Have you heard of Jupiter's Great Red Spot? Well, on Saturn there is a Great White Spot. This is a storm of white clouds that occur once every Saturnian year near the North Pole and is large enough to be seen through a telescope. Saturn also has a giant hexagon cloud at its north pole. This geometric cloud is 15,000 miles across, where 4 Earths could fit inside, with a swirling storm at its center, and extends 60 miles down into the clouds. It was captured with the Cassini spacecraft, but has been spotted by Voyager 1 and 2 back in 1988. With speculation on how this shape formed, scientists ran simulations to try and recreate it. Evidence shows that this hexagon cloud could be the product of an eastward jet stream traveling 220 miles per hour around the North Pole. Now, the North Pole isn't the only place with interesting storms. At the South Pole, the Cassini also captured a hurricane-like storm that looks like a human eye. This storm is 5,000 miles across with swirling winds of up to 350 miles per hour. Like hurricanes here on Earth, the eye of the storm is cloudless, but this gives scientists a deeper look to the inside of Saturn. The hole penetrates about twice as deep into the clouds than typically observed and uncovers a dark cloud layer at the bottom. Another storm that is located in the South Pole is the Dragon Storm. This convective storm was picked up by the Cassini in 2004 and was the source of radio emissions here on Earth. The Cassini was only able to detect these spastic waves when the storm was rising on the horizon and then stopped when in direct daylight. Scientists have stated that the Dragon Storm is a thunderstorm, that when it precipitates, it generates electricity and may be generating this energy from deep inside the planet. The core of Saturn is theorized to be hot solid iron, while the outer core consists of methane, ammonia, and water. Then there is a liquid layer of metallic hydrogen, followed by the gaseous atmosphere. Saturn's magnetosphere is similar to that of Earth and Jupiter. The Pioneer 11 spacecraft gave us the first evidence that Saturn had a magnetosphere, with the use of the magnometer. It is thought that this magnetic field is generated by the motion of the metallic hydrogen swirling in the outer core. In the magnetosphere, there is a ring of current of 10 million amperes flowing from east to west. An ampere is a unit of electrical current equal to the flow of 1 coulomb per second. The shape of Saturn's magnetosphere can be represented by a paraboloid shape, and the size of the magnetosphere depends on the varying pressure of solar wind hitting the field. If the pressure is low, the magnetopause occurs at a greater distance, where it is then inflates the magnetosphere. The magnetopause is the border at which the solar wind meets the planetary magnetic field. Although Saturn is not the only planet to have rings in our solar system, they are definitely the most beautiful. When the Pioneer 11 did a flyby of Saturn, the spacecraft transmitted images of the rings. The images were made by a photopolarimeter, which is an instrument that uses polarized light to create images. For Saturn, there were 2 images made, with one using wavelengths in the red spectrum and the second image in the blue spectrum. Then, back on Earth, these images could be processed to make color images. With the flyby, the Pioneer 11 discovered the F ring. This tiny faint ring was not visible from Earth via telescope, so being up close was the only way to know that it was there. Another interesting way that the Pioneer made images was through transmitted sunlight. This produces an image that are similar to photonegatives, where gaps in the rings appear bright and the rings themselves appear dark. Now, what are these rings made of? How about billions of pieces of icy comets, asteroids, and moon fragments that were torn apart by Saturn's gravity? These particles can range in size from a grain of rice to a kilometer in length. The rings extend out from the planet up to 175,000 miles with a thickness of only 30 feet. As you can see, the rings are banded. These bands are named alphabetically from order of discovery. Going from closest to farthest from the planet are rings D, C, B, the Cassini gap, A, F, G, and E ring. The Cassini gap between B and A ring is 2,920 miles across. But other than that, the rings are fairly close together. There is also a faint Phoebe ring in the orbit of the moon Phoebe. An interesting fact is twice every 29.5 years we are unable to see Saturn's rings. This is due to the view of the planet being edge-on. Saturn has 53 moons and 9 provisional moons awaiting confirmation. Saturn's largest moon is Titan, as well as the second largest moon in our solar system next to Jupiter's Ganymede. However, Titan is the only moon that we know of to have an atmosphere, which is mostly made of nitrogen. Also, just like Earth, it has liquids in the forms of rivers, lakes, and oceans. These oceans can be hundreds of feet deep and hundreds of miles wide. This moon also experiences rain and clouds. At the surface, the liquids are mostly methane and ethane, but below is a thick crust of water ice, potentially harboring forms of life. Enceladus was discovered on August 28, 1789 by William Herschel, and is located inside the E-ring and between moons Mimas and Tethys. Enceladus also reflects most of the light hitting its surface, making it the most reflective moon of Saturn. Just like our moon with Earth, Enceladus is tidally locked in synchronous orbit with Saturn. Most of the information we know about the surface and composition of Enceladus is due to the observations made by Voyager and Cassini spacecrafts. The Voyager discovered evidence of thermal history, including short periods of intense heating and geological activity, and then followed by long periods of inactivity. The surface features include long, narrow depressions, canyons, and craters. The northern part of the moon has bowl-shaped craters every 5 square kilometers, whereas the equatorial plains, named the Serrated Plancha, have craters every 70 square kilometers. Craters in this area show viscous relaxation, indicating mechanisms for melting and distortion of the surface. The Cassini spacecraft did its flyby of Enceladus in 2005 and revealed a plume of water ejecting from the vents in the sulci at the southern polar region. In addition to the water spewing out, scientists have determined that salt is also mixed in with similar salinity to that of Earth's. These water jets shooting out of Enceladus can reach speeds of 600 meters per second and freeze to ice soon after ejection. Much of the mass ejected from the moon makes up the E-ring, but Enceladus gains most of it back as snow falling back to the surface. Iapetus was discovered by Giovanni Cassini on October 25, 1671. To early astronomers, this moon appeared to grow brighter and then fainter over the course of its orbit around Saturn. From the Voyager missions, we were able to determine the cause of this glowing moon. Iapetus has 2 hemispheres with different amounts of albedo. Albedo is the amount of light a surface can reflect. So, Iapetus had one hemisphere with little albedo and another hemisphere that had a much higher albedo. Iapetus is also in synchronous orbit with Saturn, just as Enceladus is, where only one side of the moon faces Saturn. Scientists theorized that Iapetus pulls particles from the dark moon of Phoebe. Another idea is that there are volcanoes on the surface that distribute the dark material. When the Cassini flew by the moon in 2007, scientists lean more towards the process of thermal segregation to explain the yin-yang surface. Iapetus has an extremely slow rotation, meaning that the surfaces are exposed to the same temperature cycles. This dark material can absorb heat from the sun and warm up. Anything that easily evaporates will have to move to a colder region, leaving the dark material on one side and the icy, more reflective material on the other. Now, I will not go over all of Saturn's moons, for there are far too many, but here are some interesting characteristics of other moons of Saturn. The moon Hyperion is the only other moon, aside from the Earth's, to have a statically charged surface. The moon Mimas looks kind of like the Death Star and is also the same size and Enceladus, but with drastically different surfaces. The moon Phoebe likely came from the outside of the solar system and was captured by Saturn's gravity. This concludes my discussion on Saturn. Thank you so much for watching.